Hi, this is King of Review. So here we have to simplify an expression with several logs with base 2. So let's apply a few properties of logarithms. In this first log, we are wondering what exponent do you have to raise the number 2 to in order to make it equal 64. And by multiplying 2 together a few times, we can discover that 2 to the 6th power is equal to 64. So that means that the log base 2 of 64 is just that exponent, 6. Now we can't do the same thing for the second log because you can't raise 2 to any power to make it equal exactly 9. So let's leave that log there for a moment. In the third log, we're going to use the property that if you have a number multiplied by a log, you can bring it inside the log as an exponent. So we're going to have the log base 2 of 2/3 squared. So I brought the 2 from outside the log inside the log as an exponent. Okay, so we have 6 minus the log base 2 of 9 minus the log base 2 of, let's square this fraction. 2 times 2 is 4, 3 times 3 is 9. So we have the log base 2 of 4/9. Now we can use another property of logs, that if you have a division problem, a fraction inside of a log, you can rewrite that as the difference of two separate logs, the log of the numerator, 4, minus the log of the denominator, 9. And we keep the same base, 2, on both of those logs. Well, let's see here. We have 6 minus the log base 2 of 9 minus, now the log base 2 of 4 asks us a similar question to the log base 2 of 64. It's asking us, what power do you put on 2 to make it equal to 4? And we know that since 2 squared is equal to 4, the log base 2 of 4 is just 2. Now we still have the log base 2 of 9 sitting over here, but since we were subtracting, and then the log base 2 of 9 was a negative times a negative equals a positive, so we have a positive log base 2 of 9. And now we can see that we have a negative log base 2 of 9 and a positive log base 2 of 9, so those will cancel each other out, and all we have left is 6 minus 2, which equals 4. So there's our answer. Thanks for watching.